All right, hello everyone, it's Mr. Ops.
And Mr. Heilman.
All right, so here we go. Today we're going to talk about solving with x on both sides of the equation. And we have three approaches we're going to do it with, okay? And so the first approach, we're going to do it with algebra. And so I'm going to take this equation, and I'm going to bring all the x's on the same side of the equation. So I'm going to bring the 3x over. I'm going to do it by subtracting 3x from both sides. And so when I do that, I get 7x plus 2 is equal to 5. Hold on. I made a mistake there.
Yeah, you added it. I like that too, right? The 3x is connected to that 5 with that addition sign there. So you're good that you subtracted, but then you didn't actually subtract.
Right. So 4x minus 3x is x.
Okay.
And so we'll bring it over, and now I'm going to subtract 2 from both sides, and so x is clearly 5 minus 2 is 3. Easy
job.
as can be.
Good
All
job.
right. So that was the algebra approach. Now let's talk about the sketch approach. In order to do that, I'm going to go over to Desmos.com in the calculator part. And on this scenario here, it's quite simple. I'm going to go over this bar here, and I'm going to type in one side of the equation. I'm going to call it y equals 4x plus 2.
Why is there a y there? There wasn't one in the original question.
Good question. Okay, and so what I'm going to do, the approach I'm going to take is I'm going to make this side of the equation, I'm going to make that like y equals. And on this side of the equation, I'm also going to make it y equals as well, so that they're equal to each other. Each side will become an equation.
So you're basically making two equations with x and y,
Exactly.
both equal to y.
Yes.
Okay.
All right. And so I have that one, and I get a nice straight line, which should look familiar to you people, that you get lines. And the other one will be y equals 3x plus 5. And there's my graph there.
Wow, they're really close together.
They are really close together. But what I'm looking for is where they intersect.
Oh, that's nice.
And that's where they intersect. And Desmos, you just kind of put it near, it'll grab it. Because it
You
knows
clicked on it there, I guess. Or
yeah, I just find it, and it'll pop up nice when I hit the point.
Okay.
It knows. Somehow it knows. Oh, there it is. I had it. Now I lost it. Let me zoom in a little bit. That's a little trick too. There we go.
There it is. Okay.
Okay. And so there is my point of intersection, 314. Well, if I look back at my algebra, x was equal to 3.
Huh.
If I look at my sketch...
Oh, and that's the x component of that coordinate.
Exactly. And so I'm going to make just a quick sketch. I'm going to put on an xy axis here. An xy axis. And I'm going to make it a quick sketch. And I know that I have two lines that are kind of... Where do they go? They are... They go through the negative part. So I know that they're going to go like this. Here's one line. And make it black. And here is the other line. Okay? And I want the sketches to be that quick.
Okay, so there's like no numbers or anything on this graph.
Nope. As long as they kind of are reasonable to x-intercepts, one's on one side, and y-intercepts, that's fine.
Well, I did see that they're intersecting the x-axis on the correct side of the graph.
Exactly.
Okay, and they're also intersecting the y-axis on the top part of the graph too. So those things are right, but there's just no numbers.
Exactly. The only number I'm going to put this coordinate here, which is 3, 14. And my solution is x is equal to 3. Just the x coordinate.
Oh, that kind of makes sense too, because we just sort of invented those y's over there, right? When we had in our original question, there were no y's there.
Right, exactly. And then the one last little detail that I will ask for sometimes is that I'm just going to call this y is equal to 4x plus 2. And this one was y is equal to 3x plus 5. So that if someone looks at this sketch, they know what these lines are talking about.
Oh, right. Which is the red one, which is the black one.
Right.
Okay.
So that's good communication. Good communication. All right. And so now we've done it algebraically. We've done it graphically. The last way is with a table. All right. And again, I'm going to go to make my table. I'm going to do it two ways. I'm going to go, here's my x value. I'm going to choose one value, which was 4x plus 2, which is the left side of the equation. And I'm also going to take the right side of the equation, 3x plus 5. And I'm just going to try values of x. So if I would say x is 2, if I take 2 and I plug it in there, I get 4 times 2, which is 8 plus 2 is 10. Did you follow me on that one?
Yeah, I got it. Let me try the next one. Can we do it already?
So take the 2.
So x is 2, and right there, x is being multiplied by 3. So 2 times 3 is 6, plus 5 is 11.
Okay. These two are not equal. Okay. I want these two values to be equal. So let's try another value. Well, I'm going to guess 3 since I already know it. I take 3. If I plug 3 in for x, I get 4 times 3, which is 12, plus the 2 is 14. So I'll let you do the next one. So I take the 3, plug it in.
Multiply it by 3. Gives me 9, plus 5 is 14.
That's what I'm looking for. When the left side equals the right side, this is the x that makes it true.
So this is kind of a guess and check method, isn't it?
If you don't have technology, but watch how sweet this is. If I go over to Desmos, I can go here and add an item. I'm going to add a table. And here, I'm going to put in 4. And because this is x1, I'm going to call it x1 plus 2. And here, I'm going to go 3x1 plus 5. And I'm going to let Desmos do the work for me. I'm going to do 1, 2.
Ooh.
And it just makes it. And I can see right there on number 3, when x is 3, I have the two values of 14. But it is kind of a guess and check method. If this answer is like 3.712, the table doesn't work very well.
Right, okay.
Okay. And you can also see that these points here are coordinates on these two lines as well.
Oh, it shows up over there. Nice.
Right. And we're looking to see which one are they equal, and that's going to be when x is 3. Right. So in solving these equations, algebra we can do, sketching we can do, and the table we can do. Lots of valuable methods to solving equations.
Very nice.
Okay. Well, here's another one. Let's do this one as well.
Oh, okay.
It's a little bit messier. We'll start off with algebra, since it's right underneath for no other reason than that. Okay, so you want to take me through this there, Mr. Howman?
I can try. There's x's all over the place, and I know in the end I want to get all my x's together. But they're stuck in these parentheses. Yeah?
Yep.
So I think I need to somehow get rid of those parentheses. So let's, that parentheses there with a 2, that means there's multiplication. So let's distribute the 2 to the x and to the 1.
Right. Okay, so then when I do that, I get 2x plus 2.
Okay, and then you're just subtracting that other stuff in the parentheses, right? So that should be easy.
Right, so if I go minus x minus 4, easy, right?
Yeah, super easy. But wait a second. I think these parentheses mean I'm supposed to subtract the whole thing that's inside of the parentheses. That needs to be subtracted.
Ooh. So it's almost like there's a -1 here, and I'm distributing that -1.
I remember that trick. I use that trick all the time to remember that negative goes to both the x and the -4.
So which is the mistake?
Well, this x started out as positive, and it changed to a negative here.
Yep.
But the 4 was negative. It should change to positive.
Excellent. I like that better.
Okay.
Super. We're on to something here. And so then we collect like terms.
Yeah.
I'm going to simplify this side. I get 2x minus an x is an x, and a 2 plus 4 is 6 minus 5x.
Okay. I like to have positive x's.
Me too.
So when I see that there's negatives on one side and something on the other side, I always try to get rid of those negative ones. And let's add, 5x to both sides.
And so that's going to give me x plus 5x is 6x plus 6 is 0.
There's a 6 that we want on the other side, so subtract 6 from both sides.
Okay, so it's equal to -6.
And then we need to get x alone. That 6 is connected to that x by multiplication. So we'll do the inverse operation. Let's divide by 6.
Super. And so then x is -1.
Okay.
Okay, so that's algebraically how we can do it. And again, if we're going to do it graphically, we need to... Do you want to write that down so we can save it? We need to sketch this on that side. I know what the one side is. That's easy. That's -5x.
I didn't get it.
So y equals -5x. Oh, call it back. Minus x minus 4. All right, so y equals -5x. And the other one is y equals 2x plus 1 minus x minus 4. And one of the things I love about the graph is Desmos does all the algebra for me. And I can purely use this as a solution maker. Okay? And again, just to reemphasize, I made this whole bit one side of the equation, y equals, like a y equals, and I made this side another side, like a y equals.
Right, okay.
All right, and I know I have, I can make a graph. And when I look at here, boom, the point of intersection.
This looks like it's almost 5. Yeah. Okay, that's the
There it
y
is.
value, and -1 is the x value. Okay.
All right, so going through the origin, going here. All right, so when I make a quick sketch of that, I'm going to go, here's one line. Here is another line. Oh, another line was here. And -1, 5 was the point of intersection. So this is going to be the point -1, 5. So x equals -1.
Okay.
And if I tidy this up, I can say y is equal to -5x, and y is equal to 2x plus 1 minus x minus 4.
So that's all the labeling you need to do there.
That's all the labeling I need to do. I have, these graphs are reasonable. Are they exactly? No, but it's close enough to know that I'm in the right track.
Okay.
Okay? And this sketch, I want this to be quick. I don't want you to laboriously do this.
Right.
Just quick.
Okay.
Quick and dirty. You have the sketch here. Okay. And then finally with the table, well, let's see if I can copy and paste a little bit. Copy that. Let's make a table. I think I can copy and paste. Oh, I like that. And we'll copy and paste that. Except I have to put x1.
Yeah, I was just going to ask, those are just regular x's, I think.
Right.
So you're just typing a 1 after that x and it's doing that?
Yep.
All right.
And so let's start at -2, -1, 0. Now it recognizes what's going on. And again, I can see that this
That's
produces the right value. So if I would plug -1 into this part, it will work nicely. And I'm going to, since I have technology, I'm going to make a quick screenshot and plug it in to here's my table. Here's my table.
Cool.
All right. Great. So when solving equations, we have three methods. They are all equally valuable. And when I'm doing my higher level mathematics, I more often than not just crunch right to the graph and just find me the value.
Yeah, it's probably different problems. These different ways are more useful. One more useful than the other. And you kind of got to read the question, I'm thinking, and decide on which route is best for you. But right now we're practicing all three.
Exactly. Perfect.